The previous video, we spoke about the kinetic molecular theory of gases. In this one, we're going to be talking about behavior of real gases, that is the deviation from the ideal gas behavior. Now, before we start discussing about the same, I'd just like to recap on the Boyle's law. So according to the Boyle's law, at constant temperature, the pressure of a fixed amount of gas and the number of moles n of a gas varies inversely with its volume. And we got this particular graph from the Boyle's law. And we got the equation P is directly proportional to 1 by V. Now, what was observed was that not all the gases followed this particular rule. So not all the gases actually followed the gas laws as well as the kinetic molecular theory of gases under all conditions of temperatures and pressures. And this meant that a gas which follows these under all temperatures and pressures is an ideal gas, and the one which does not is a real gas. And generally, real gases follow the ideal behavior under low pressures as well as high temperatures. Now, when the pressure is going to increase or the temperature is going to decrease, the gas is going to deviate from the ideal behavior. Now, like for example, oxygen, nitrogen, carbon dioxide, and especially carbon dioxide, we'll be learning about carbon dioxide in detail in the next few videos. After next few videos. And there you can actually see that at a particular pressure and a particular temperature, there is a very very low pressure and a high temperature, it will tend to follow the ideal behavior. Now, what was decided was that the real gases, they don't tend to follow the gas laws under normal conditions of pressure and temperatures, and they need a specific set of conditions to do the same. Now, here we have two graphs that we'll be discussing about. The first one is the plot of PV versus P for real gases and ideal gases. So here, this is the one which we learned in the Boyle's law. You have P on the x-axis and PV on the y-axis. So based on the Boyle's law, for a gas, you should get a straight line at a particular temperature. And this is what was discussed when we talked about Boyle's law. But in reality, two types of curves were observed. One was just a straight line like this, and the other was like this. Okay, so what it meant was that at a particular temperature, our gases like carbon monoxide and methane, they tend to move down. There is first a negative deviation, that is, it goes down, and then it goes up, right? So as the pressure increases, the PV is first of all, as the pressure is increasing, PV is first decreasing, reaching a minimum value, and then it is increasing with increase in pressure. And this particular line is actually crossing the ideal gas line, and then it is constantly giving us a positive deviation. On the other hand, for gases like helium and hydrogen, okay, as there is an increase in the pressure, there is an increase in the value of PV. Okay, even then you have a straight line, but despite all of that, they actually don't coincide with the ideal gas line. Okay, and so that meant that these gases are not following the ideal behavior at these particular set of pressures. Okay, the next one over here is the plot between the pressure and volume. And for Boyle's law, this is how it's supposed to look at different temperatures. This has been given. So for one particular temperature, we assume there's just going to be one line. Now, in case of this curve over here, you have the one in red is for an ideal gas, and the one in blue is for a real gas. Now, if a real gas always behave like an ideal gas, then no matter what, this and this should have coincided. Okay, but if you notice, as the pressure is high, comparative to this place, the pressure is higher over here, right? So as the pressure is decreasing, the real gas is actually approaching the ideal gas behavior. Okay, and this means that at high pressure, the measured volume is going to be higher than the volume which was calculated. And at low pressures, the volume is actually lesser than what is calculated. Okay, so here we've learned just about how pressure and volume. Basically, we only talk about pressure, but as such, real gases tend to behave like ideal gases at low pressures as well as high temperatures. But since we took the example of Boyle's law, we only talk about pressure. Okay, so with that, we're done with the basic introduction of the deviation of gases from ideal behavior. First of all, the various gas laws like, Boyle's law, Avogadro's law, all of this is not followed by all the gases under all conditions of temperatures and pressures. So there are certain specific conditions of temperatures and pressures where these gases, which are real gases, behave like an ideal gas. An ideal gas is the one which follows the gas laws under all conditions of temperature and pressure. So it was noticed that real gases, which are basically the ones which we see around, which we don't see actually, but which are around us, so these tend to follow the ideal, or rather, they tend to follow the ideal gas behavior, or they follow the gas laws under certain set of pressure and temperature, that is low pressure and a high temperature. In this video, we talked about how pressure is affecting the behavior of the gases. We compared two graphs, P versus PV, where we have two types of curves which are observed. The first one shown by carbon monoxide and methane, where you have a first decrease in the value of PV with the increase in the value of pressure. And then after a minimum value is reached, it crosses this ideal line and there is an increase. On the other hand, you have curves which are just direct with the increase on the value of pressure, there is an increase in the value of PV. But no matter what, they're not actually coinciding completely with the ideal gas. Similarly, in the pressure versus volume graph, if you notice at the top, when the pressure is high, the volume which is observed is higher than the volume which is calculated. So if you extrapolate this to this value is here and this is going to be approximately over here. So there is obviously a difference in terms of the volume which is expected and calculated. And at lower pressures, the volume which is expected is higher than that of the calculated, sorry, the volume which is seen or observed is lesser than that of the calculated volume. So with this, we understand that not all these gases are not behaving according to the various laws that we've learned up until now, and we'll be learning about why that is the case in the next video.